Good morning, guys. This is Anjani Kumar, Electrical Department, Newton's Group of Institutions. In last class, we started how the motor will work. Right? Today, I'll continue the motor, how it will work. Right? You know about how the motor will work. So the motor, which converts electrical energy into mechanical energy. I have a magnet. So there is a flux from north pole to south pole, that is a constant, and I have a conductor placed in a magnetic field. So what happens? You are applying electrical energy, right? When current flow through the electrical means you are giving current to the conductor. So when current to the conductor according to the Fleming's law, what happened? According to Ampere's law, what happened? When current flow through the conductor, the magnetic field will be produced around the direction of a magnetic field will be exerted by will be given a Fleming's rule. If a conductor current is in the direction, the field will be in this direction, right? In this, you have two fields. One is the main field and one is the conductor field. If you clearly understand, on the top of a conductor, the main field and conductor field both are aiding. The bottom of the conductor, the main field and the conductor field both are opposing. I clearly explained in the last class. So what happened? Top of the conductor, total flux will be heavy, and the bottom of the conductor, total number of flux will be very less, because those two are cancelled out. No flux on the bottom. So what happened? At the top of the conductor, more flux means more pressure. So what happened? Definitely the force will be created. Due to that force, the conductor starts moving. Alright, like this, you are getting mechanical energy. So this is for one conductor. You have a more number of conductors. When a more number of conductors starts rotating. Now one point you should clearly understand. Now, okay, motor principle is over. You're doing electrical and my conductor starts rotating, you'll get a motor. Now see, when a conductor starts moving, the rotational conductor will also cut the main field flux, right? You just imagine. My conductor starts moving, no problem, okay. When a conductor starts moving, it also cuts the main field, north pole, south pole, main field flux is there, man. It also cuts the main field flux. Definitely there will be another EMF will be developed. So that EMF we can call it as back EMF. So we can call it as a back EMF. That is nothing but the motor which is having a generator action. So that can be denoted by the EP. You just imagine. So motor principle is over. Okay, you are giving electrical, you are getting mechanical, means making my conductor starts rotating. When a conductor starts rotating, definitely it will cut the main field flux. Now, according to the generator action, change in flux will be created and EMF will be generated. So that EMF we can call it as a back EMF in the motor. Now, from the equivalent circuit of a motor, you are giving a voltage. What happened? The current will flow through the motor and the motor starts rotating. Now what is the equation? V is equal to back EMF generated na? EB plus IA RA. IA is nothing but current flow through the motor. RA is nothing but internal. This is one important issue you have to imagine. In a generator, the current will be outwards because current will flow through the load. In a motor, you're giving voltage means voltage to your motor means current flow through the motor. That's you need to understand. Got it now? V is equal to EB plus IA RA. IA RA is nothing but a drop. So EB is nothing but back EMF, nothing but generated EMF. Now similarly, so here also excitation is there. Separately excited motors, shunt excited motors. We'll discuss those. That's not the basic concepts. Separately excited means you are exciting your magnet to a different DC source. After that, self-excited means generated EMF. You are exciting. All these things we'll discuss. You already studied because in the past semester you studied about all this information. Now the basic important concept is why we require a starter. That is very, very important. So why we require a starter? So you know that V is equal to EB plus IA RA. Alright? See, at the time of starting, right, motor switch on చేసావు, voltage will be applied across the motor. So what happened at the time of starting? Is there any back EMF generated? So the back EMF is 0. So V is equal to 0 plus IA RA. V is my applied voltage. So what are the applied voltage? If it's a single phase motor, 230 volts is equal to 0 plus IA. You don't know IA. RA is very less, 0.05 ohms, very less internal resistance is. So what is IA? What is IA? IA is equal to V by RA. At the time of starting, what I am saying, IA is equal to V by RA. So what is a V? 230 volts. What is RA? 0.05. 230 by 0.05. What happened? Around, what happened? 6,000. Around 5,500 amperes of current will flow through the motor. So what happened? The motor will get damaged. Because of there is no back EMF action in the motor at the time of starting. So we need to protect the motor from that current. So that's why you require a starter in the motor. Got it now? Then you are applying. Then what happened? Then back EMF starts increasing. Once motor started, the back EMF starts increasing. You don't have a starter. So what type of starters that you have? You have 3-point starters. Is there 4-point starters? You know everything. The function of a starter is that at the time of starting, all the resistance that are connected, because high resistance means current will be lesser. After that, my back EMF start increasing, the resistance are going to be disconnected. If you put resistance until, definitely you will get losses in the machine. That's why the resistance are going to be neglected. So this is the functioning of a simple functioning of a starter, right? So with this we'll completed the DC generator and how the DC motor, how the working of a starter, and a DC generator concept. We'll discuss about critical speed, critical resistance, and self-excited, separate excited DC generators, and all these things we'll discussed. And the next class we discussed about AC machines, how the induction motor will work, how the rotating magnetic field will be developed in the machine, what is the synchronous speed, and what is induction generator, and why we can't apply a DC to an induction motor, and after that the working of a transformer. In the next class we'll discuss about these two things, and after that we'll discuss about how the alternator will work and how the synchronous motor will work. So with that we'll finish these basic electrical machines concept. So with this you'll get a glimpse, like you will get idea how the machines will work. You get a little bit idea. That's enough for me. You don't have that much knowledge. Just analyze. No, machine is like this, and a generator is like this, a motor is like this. That's enough for me. If you understand that type of concept, that's enough for me from my videos. And thank you very much. Stay home, stay safe, and make your surroundings also safe. Bye.